You think hot water just magically shows up when you turn the handle, but here's the uncomfortable truth nobody tells you. In a long blackout or energy collapse, hot water disappears faster than light. And the way modern homes heat water today is the difference between staying clean, staying warm, and spiraling into slow misery. Listen closely, because the tech hiding in your walls right now is quietly rewriting the survival math, and most people don't even realize they're standing on top of it. For most of human history, heating water meant burning something and hoping you didn't waste too much of it. Wood, coal, oil, muscle power, fire was life, but it was also loss. Heat drifted away into the air, into stone walls, into nothing. Old homes heated water like a campfire heats a pot. Brute force, massive waste, and constant fuel hunger. That worked when forests were endless and nobody cared how much smoke filled the sky. But modern homes had to adapt because energy stopped being cheap, grids became fragile, and efficiency stopped being a luxury and started becoming survival strategy. Here's where things quietly got interesting. Modern water heating begins with a simple truth from physics. Most energy loss isn't dramatic, it's invisible. Heat escapes through surfaces, through time, through waiting. Traditional tank heaters were basically slow leaks of money and fuel, keeping 40 or 50 gallons hot 24 hours a day, even when you were asleep, at work, or long gone. The tank didn't care. It kept bleeding heat into the room, hour after hour. Modern systems looked at that and said, why are we heating water that nobody is touching? That single question led to one of the biggest efficiency jumps in residential history: on-demand heating. Tankless systems don't store heat. They ambush cold water at the exact moment you need it. Cold water flows in, high-intensity heating elements, or burners, fire instantly, and the water exits hot within seconds. No storage, no standby loss, no wasted nighttime heat drifting into your basement. In survival terms, this means energy is spent only when there's a direct biological need. No idle consumption, no bleeding resources while you sleep. But that alone wasn't enough, because energy input still mattered. Burning gas or pulling electricity straight from the grid during peak hours is expensive, fragile, and dependent on infrastructure that fails under stress. That's when modern homes started stealing ideas straight from thermodynamics textbooks and industrial refrigeration labs. Heat pump water heaters don't create heat at all, they steal it. Air around your home contains stored thermal energy, even when it feels cold to you. A heat pump grabs that low-grade ambient heat and compresses it, concentrating it into water. It's the same principle that keeps refrigerators cold, just reversed. For every unit of electricity consumed, a heat pump can deliver 2 to 4 units of heat. That's not marketing hype, that's physics. In survival math, it means you're no longer paying full price for heat. You're leveraging your environment like a scavenger, pulling usable energy out of air that would otherwise be ignored. This becomes terrifyingly important when systems fail. During grid strain or partial outages, a heat pump water heater can operate on dramatically less electricity than resistance heaters. Pair it with a modest solar array or backup battery, and suddenly you're one of the few houses that can still produce hot water while everyone else is boiling pots like it's the 19th century. Clean water is health. Warm water is morale. Morale keeps people functional longer than calories do. Collapse doesn't usually kill you instantly. It wears you down. Hot water quietly slows that process. Then there's insulation, the most boring word in survival prep and the most lethal when ignored. Modern water heaters wrap tanks and pipes in thick multi-layer insulation that borders on absurd compared to older models. Pipes are no longer allowed to run naked through crawl spaces and unheated walls. Every exposed inch is a heat leak. Modern codes and designs treat hot water like blood in an artery. You insulate it because loss weakens the system. In a blackout scenario, insulated pipes mean the water already inside stays warm longer. That extra 30 or 60 minutes of retained heat can be the difference between washing properly and choosing which discomfort to tolerate today. This section is based on practical field survival experience rather than formal academic sources. Another quiet revolution is temperature control. Older systems blasted water to a fixed high temperature, then relied on mixing valves to dilute it at the faucet. That's energy thrown away on purpose. Modern systems use precise thermostatic controls and smart sensors to heat water only as hot as needed, adjusting dynamically based on demand. Less overheating means less scaling, longer equipment life, and lower energy input. In collapse terms, durability is king. A system that runs cooler, cleaner, and smarter fails slower. Scaling from overheated water destroys elements and clogs pipes. Modern efficiency isn't just about saving money, it's about reducing failure points when replacement parts no longer exist. And then there's solar thermal, the most ancient idea upgraded with modern brutality. Heating water with sunlight is older than civilization, but modern systems use evacuated tubes and selective coatings that trap heat like a thermal prison. These systems can deliver scalding hot water, even in cold weather, because they're harvesting radiation, not air temperature. In stable times, they slash utility bills. In unstable times, they function completely off-grid. No inverter, no fuel delivery, just sun, physics, and gravity. A rooftop solar thermal system turns your house into a silent energy harvester, operating whether the grid likes it or not. That's not green ideology, that's resilience. Modern homes also learned something uncomfortable. Most water heating energy is wasted at the tap. Long pipe runs mean you wait while gallons of cooling water drain uselessly. New designs shorten pipe distances, use recirculation pumps with timers and motion sensors, and sometimes even locate heaters directly near bathrooms. Hot water arrives faster, less water wasted, less reheating required. When infrastructure fails, water becomes heavier than gold. Efficiency at the tap isn't luxury, it's conservation under pressure. The final layer is intelligence. Smart water heaters monitor usage patterns, grid stress, and energy pricing in real time. They preheat when energy is cheap and reduce output when systems are strained. In emergencies, they can be manually overridden to operate in low-power survival mode. This isn't about convenience, it's about adaptive behavior. A system that can think even a little buys you time. Time is survival currency. So here's the quiet, unsettling conclusion. Modern homes don't heat water better because people wanted comfort. They do it because inefficiency became unsustainable. The same pressures that drive collapse, resource scarcity, grid fragility, energy volatility also shape the technology sitting in your basement right now. If you understand how it works, you can stretch it, adapt it, and survive longer with less. Hot water isn't a luxury. It's a signal that the system is still holding together. And when everything else starts to fail, the houses that figured out how to heat water efficiently will be the last ones still steaming in the dark.